experiment was done in order to, as I was telling, to verify the theoretical results, first of all, benchmark. And this is what it is. We compare the theoretical results with the experimental results. Nobody on earth can do it, that every point will fall on this, because there will be errors coming because of experimental as well as theoretical things. But if it falls within certain range of confidence, I can say that qualitatively it definitely follows it. Especially which away from the operant section, it is matching much better, and as a condenser section, the matching is very good, etc. So we believe that our results are sufficiently good enough in order to do performance analysis. And we also calculated the error percentage in this, which fell within something like 5 to 6% average error. Then, based on this, we came back to the theoretical model and we changed all these parameters and did more and more theoretical studies so that we get theoretical results like this for various things, including the effective thermal conductivity. And ultimately, using the values of the effective thermal conductivity variations, which I got by changing individually various parameters, we fit the correlation for the effective thermal conductivity. So if I can put the values inside for an unknown case, I'll be able to predict how much is going to be the effective thermal conductivity. Now, I can also use this for an optimization. So using this minimization, maximization of K effective as the objective function, I use optimization. Maybe I can use conventional method where I do a search procedure or something like that. I know how to do it, but I don't know whether most of my students will be able to do it right now because they have software. When you have a software, you forget about the theory. You forget about learning it, is it not? Because you have a software. Okay, it's a black box. But anyway, my student could do it using a software, and then he optimized and got the best combination of various parameters of this particular case for a wire sandwich like this. Yeah, Dora is it's a commercial software. It's a free software. It's an open source software. It basically does a grid search only. It's a search procedure basically. So from these are the kinds of conclusions that we take qualitatively and quantitatively about the vapor velocity distribution, temperature drop, instantaneous effective thermal conductivity, how it varies with the parameters, etc. And these are some of the information that will give us light when we try to design new heat pipes. Stopping at that for this analysis, I just thought that I'll show you some interesting things apart from this. Some designs, just qualitative, for the use in computers, for example. Similar things Dr. Carpenter was also showing. But these are all made of micro heat pipes, not mega heat pipes. So this is another micro heat pipe called ceramic chip carrier. This is a flexible polymer micro heat pipe. It's actually made on a flexible polymer membrane by cutting all these grooves. If I close it using another sheet of polymer, then all these channels can work as micro heat pipes. Then some fabricated big pattern which can also be used in order to enhance the performance of the micro heat pipe by doing it. These are all very, very small. It's very of the order of a few microns, 1 or 2 microns inside. This is another big pattern which is fabricated by it. Of course, this is not done in India, it's done abroad. Coming to this research needs. So I hope within this short span of time I was able to convey some things in a nutshell about this particular design and then at least some vague idea about how it's going forward as far as research is concerned. I hope so. Some of the research needs probably which we can think about. One is analysis of heat transfer and fluid flow process with appropriate non-dimensional formulation. So far, many people have worked on non-dimensional formulation on heat pipes, not micro heat pipes, not much on heat pipes. The first one probably a suggestion of a non-dimensional formulation on the analysis of heat pipe came from Carpenter, Cohen, and Peterson. When was that? 2000.